So again, sorry for the disturbance, but I got call from the doctor, so that's why I discontinued. So here I was saying that in the question we are asked to provide a phase shift of 90-degree lagging. So 90-degree lagging, you should know if you will use, and it is said design an RC circuit. You can use RL, but it is asked in the question that using RC circuit. So if it, you know, it is RC circuit, so and it should be a lagging circuit, you have to measure the output across what? Capacitor or resistor. You have to measure the output across the this capacitor. Okay, so I told you when XC is equal to R, you will get a phase shift of 45-degree. So what will you do for a 90-degree phase shift? So what we do, we will use two RC networks that are connected back to back, means that are connected in cascade. So means one circuit will provide a phase shift of 45-degree and the second circuit will again provide a phase shift of 45-degree. So here I was drawing it for the first circuit, but then I decided to show you the complete diagram. Okay, so if you will see here, I have two RC circuits that are connected back to back. So this circuit, this my circuit, this resistor and this capacitor, it will provide me a phase shift of 45-degree, because this is XC is not nothing but minus 10J, but here when we talk we only take the magnitude. Okay, so it is minus 10J and here R is 10. Okay, so tan inverse 10 divided by 10, it is 45-degree. So it will provide me a, so whatever voltage I will get here V1, it will be 45-degree lagging compared to Vi. Okay, so now I will get V1 here. Here the output is V1. Okay, which is shown here as well. So now I will consider this circuit. Now look at this circuit. You have a voltage V1 and you have another RC circuit. So this voltage, it is already lagging behind the input voltage by 45-degree. So and this V0 voltage, it will, this is an RC network, again second RC network. So this will again lag behind this voltage by 45-degree. Okay, so this is lagging behind this voltage by 45-degree and this is lagging behind the input voltage by 45-degree. So what will be the total phase shift between this voltage and this voltage? It will be 90-degree. I will show you how. So these are two, I am saying this is one RC network and this is another RC network, and they are connected in cascade. This is called as cascade connection. Cascade connection. Okay, so I will say, I'm saying that, so there should be a phase shift of lagging phase shift, that is lagging phase shift of 90-degree between V0 and Vi. V0 output and Vi is the input. So let us see, is it so or not? So here I am saying, so I am saying this is 10 ohm R, and this C is nothing but minus 10J, again R10 and C minus 10J. This is Vi, this is V1 and this is V0. Suppose you want not 90, you want 145. So what will you do? You will use one more RC network. Okay. So first I am saying this dotted circle, I will calculate the impedance of this dotted circle. So what is the impedance of this circle? If you will see from this point, it will be 10 minus 10J in parallel with 10 minus 10J. Okay, because this plus this is 10 minus 10J and this is minus 10J. So the total, this impedance will be, I am saying representing it by Z, is equal to minus 10J parallel 10 minus 10J, excluding this 10 ohm resistor. Okay, I am looking from this point, this circle, dotted circle, I am calculating the impedance of this dotted circle. So it is coming out to be 2 minus 6J. Okay, so what will be V1? V1 will be nothing but input voltage V, okay, multiplied by the total impedance. Total impedance is what? 10 plus this whole impedance Z. Sorry, V1 will be Vi, input voltage, divided by total impedance. What is the total impedance? Total impedance is nothing but this impedance Z plus this 10 ohm resistance will be equal to Z plus 10. So multiplied by the impedance Z. Okay, because this Vi divided by Z plus 10, Vi divided by whole impedance, which is nothing but Z plus 10, it will give you the current I. So this current is flowing in this whole impedance. So this will give me the drop V1. Okay, so I will show you here like this. I am saying this is this and this is my, okay, I am showing this is V1 and this is Z and this is 10, this is Vi. Okay, so I am saying what will be V1? V1 will be nothing but Z into current I. Suppose this is current I, this is V0 plus minus V0. Z into I, this current is flowing in this. So Z into V will be nothing but Z into I. V will be nothing but Z into I. This is Z, this is I, so it will be V1. Okay, so what will be I? So Z, what will be I? I will be nothing but input voltage V1, Vi divided by whole impedance. Whole is 10 plus Z, 10 plus Z. Okay, so this is what I am doing here. V1 is equal to Vi multiplied by Z divided by Z plus 10. So I am getting, what is that? 2 minus 6 divided by Z plus 10 is 12 minus 6J multiplied by 60. 60 is Vi. Okay, it is given in the problem. So I am getting V1 is equal to 28.28 angle minus 45. So you can see minus 45 V1 and Vi was nothing but 60. So this was 60 angle 0. This is 28.28 angle minus 45. So you are getting a phase shift of minus 45 here. Means this V1 is lagging V1 is lagging Vi by minus 45 by 45 degree. Okay. So in the next step, what I am doing, I am calculating V0 now. Okay, so I will again draw the circuit and I will see what is V0. So V0, if you will look here, this is Vi and this is V0. Means you are getting Vi here. This is Vi. I will again draw it here on this page. So I am saying this was my V1. This was V1, this was 10. This is minus 10J and this is V0. Okay, so this is here. I am saying I got the value of V1. Okay, so now I have this 10 ohm resistor and minus 10J capacitor. So what will the V0 will be equal to? V0 will be equal to Vi divided by 10 minus 10J multiplied by minus 10J. Okay, so this V0 is nothing minus 10J divided by 10 minus 10J into V1. Okay, so it is not V1I, this is Vi1 and this is V0. Here I am showing. So V0 is coming out to be 20.00 angle minus 90. So you can see that V0 is 220 angle minus 90 and Vi is 60 angle 0. So what is the phase shift? Phase shift is 90 degree and this is lagging phase shift. And what about the magnitude? Magnitude has been reduced from 60 to 20, means only 33% of the magnitude will appear across the output. Okay, 33% of that of input, okay, will appear across the output. Got it? So and the next I am giving you a homework. Okay, so what is the homework? The homework is that if you if a 10 volt is applied at to input, means if Vi is equal to 10 volt, find the magnitude and phase shift produced by a 5 kilohertz. Okay, 5 kilohertz means you have to consider, you can see here omega, this inductance is in Henry. You have to convert this Henry into ohm, means it is in L. You have to convert this L to XL. Okay, and omega is given as 5 kilohertz. Okay, got it? So this is 5 kilohertz, this is milli, so it will be converted into ohm. You have to convert this inductances into ohm. Okay, so then you have to, what you have to do, specify its phase shift is leading or lagging. You have to calculate what is V0 and is V0 leading or lagging Vi, and if it is leading or lagging by how much, you have to calculate that. Okay, you have to calculate V0 magnitude and you have to calculate the phase shift theta as well. So this is your homework. You will show me, you will solve it on your notebook and you will send me the pics. WhatsApp me the pics of this question and the previous question that I gave you, which is nothing but this mesh analysis technique. So that is all for today's lecture. In tomorrow's lecture, I will start with the superposition theorem. Why superposition theorem is important in AC circuit, very much important in AC circuits, and Norton's. Thevenin is simple because we studied Thevenin in DC. So the same procedure will apply to Thevenin in AC as well. However, in DC, I skipped Norton's theorem. I told you that Norton's theorem you will complete yourself. However, in case of AC, I will show one numerical related to Norton's. So that is it. That is it. It for today. Thank you very much.